today we're going to start the Unit 6 packet, Exponentials and Logarithms. Now, your first page looks a little bit different than mine. I added in this page into the flip chart earlier today because to be able to work the problems on page 1, you're going to have to know some properties of exponents. Okay, we're not going to talk about all these today. We're just going to talk about a few. The first one we're going to talk about is something that you're pretty familiar with. It's called the product of powers property. Say that you have something like x squared times x cubed. What does that equal? X to the fifth, right. Whenever you multiply two terms and they're the exact same base, see a times a or x times x, it tells you to take your exponents, which they call b and c, and add them up. Okay, that's the product of powers property. You're all very familiar with that and know how to do it. You've probably just never called it by that name. Okay, now the next property that we're going to talk about is the negative exponent property. This one might be a new one to you. Say that you have something like x raised to the negative 2. And then all of your answer choices do not look like that. It's because sometimes they prefer that you not leave a negative exponent. So you could rewrite it so that the exponent is positive by rewriting it like this, 1 over x squared. And now the exponent is positive. Now let me prove to you that that's just not made up. Say instead of x, we put in a number. Let's put in 2 to the negative 2. Okay, I'm going to type that in my calculator. 2 to the negative 2 is 0.25. Now, let's rewrite it so that the negative is not there. We would need to write it as 1 over 2 raised to the positive 2. Now, let's calculate that. 1 divided by 2 squared is still 0.25. See, they're equivalent. It's just two different ways to write it. So, really, it just depends on the worksheet you're doing or the quiz or test. If you work out your answer and that's what you end up with, but that's not one of the choices, maybe consider writing it without the negative exponent. So you'd have to rewrite it like that. Okay? You can't just simply, what? No, but I don't think you'll need it. I mean, I can get it for you if you feel like you need it, but after today, I think you'll see that you don't need it. Okay, so, like, you can't just simply rewrite it like this, because obviously that's not the same thing. We already saw on the calculator that 2 to the negative 2 is 0.25. What's 2 squared? 4. Is that the same thing? No, that's why it has to be rewritten as 1 over. Because think about it. If 2 to the negative 2, when we calculated it, we saw that it was 0.25, right? 1 over 2 squared is 1 over 4. Well, isn't that 0.25? So that's why you have to rewrite it like that to get the negative away from the exponent. Okay, so that is the negative exponent property. The next property we're going to talk about is a power of a power property, or power to a power. See how they have a term and it's raised to an exponent, but then raised to another exponent? What did they show to do with those exponents? By what operation? Multiplication. Look, they're just touching, which means multiply. So like if you have x squared, but that x squared is cubed, you would multiply the 2 and the 3 and get x to the 6th power. Okay? So don't confuse it with the product of powers. Like if it had been x squared times x cubed, that's x to the 5th. Because you add it when you're multiplying two different terms. But when you have one term and it's a power to a power, you multiply the two powers. Okay? Now the last property that we're going to talk about is the rational exponent property. And instead of like trying to explain it with just all these letters, I'm just going to do a few examples. Say you have the cube root of x, but the worksheet you're working on says that they don't want any answers left with a radical symbol. They want them all left with a rational exponent. You can rewrite the cube root of x as x to the 1/3 power. Okay, so let me show you. You can rewrite it like this. X to the 1/3, and it's the same exact thing. Now, I can prove it to you by using a number instead of x. Say we did the cube root of 8. Okay, so if I calculate the cube root of 8, I have to go to math to get to the cube root option. It equals 2. Okay, well I could rewrite it as 8 to the 1/3 power. 8 raised to the 1/3 also equals 2. It's the same thing. It's just two different ways to write it. Okay? And the reason it comes in handy is when you start solving equations, it might be easier to convert it to this to solve for x instead of this. Okay? It all depends on what you're working with is when you'll decide which way to go. Okay, so if the cube root of x can be rewritten as x to the 1/3, what do you think the fourth root of x could be written as? X to the 1/4. What about the fifth root of x? Right, x to the 1/5 power. Okay, so obviously they're called what they are for a good reason. The cube root of x, because that's a 3. Okay, and when we say x to the third, can't we call it x cubed? Okay, the fourth root of x, because it's a 4. The fifth root of x, because it's a 5. So how would you rewrite the square root of x? X to the 1/2. Okay, because think about it. Cube root, fourth root, fifth root, square root. There's an understood 2. It's just never visible, but it's there. So that's why you rewrite that as x to the 1/2. So that's what the rational exponent property says. So let's try some on this first page. The first thing I want you to do is kind of ignore the 5 for just a second. Let's just pretend like it's not there. Let's just rewrite the cube root of 2 as a rational exponent. What would that look like? 2 to the 1/3. Okay, now let's see where the 5 comes in. If that's all to the 5th power, now look, we have a power raised to another power. What do you do in that case? Multiply. So it would equal 2 to the... Okay, let's look at it up here. 1/3 times 5. Couldn't you easily turn that into a fraction by putting it over 1? 1 times 5 is 5. 3 times 1 is 3, so 5/3. You don't need a calculator today because they're that easy. Okay, so let's look at number 2. The first thing we're going to do is rewrite the fourth root of 10 as a rational exponent. What will that look like? 10 raised to the 1/4. And then it's cubed, so now what do we do? Right, you multiply the two powers and you'll get 10 raised to the 3/4 power, or the 3/4 power. Okay, why don't y'all try 3, 4, 5, and 6, and then we'll go over them. Okay, so number 3, the first thing we would need to do is rewrite the cube root of 7 as 7 to the 1/3 power, but then it's squared, so now we have to multiply those, and so our final answer is 7 to the... Right. Okay, for number 4, the first thing we need to do is rewrite this as 10 raised to the 1/5. And then there's no power, so you're done. Okay, number 5. The first thing I need to do is rewrite this fifth root of 2 as 2 raised to the 1/5. And then it's also raised to the 7th power, so that'll give you a final answer of 2 to the right. Number 6, I rewrite this as 2 raised to the 1/6, and then raised to the 5th, so it becomes 2 to the 5/6. Okay, now skip to the next page. You'll be able to do those in a minute. All right, number 11. What should I do first? 7 raised to the 1/2, right? Because that's an understood 2 there. This is square root. But then that's raised to the 5th power, so the final answer is 7 raised to the 5/2. Okay, number 12. This is different because we have a fraction. So just take it one step at a time. The first thing that you're going to do is rewrite the denominator. Instead of the 5th root of 2, what could we do? Right, 2 raised to the 1/5 power. Now, that answer is completely acceptable. But say on the test, that's not what you see. Maybe they were okay with negative exponents and they left it as 2 raised to the -1/5. Those are the same thing. Remember when we were talking about the properties, if you have something raised to a negative exponent, you can make it positive by putting in the denominator under 1. So you could reverse that and go back to the negative exponent. Okay, now let's look at number 13. Just one step at a time. First, let's do the denominator. The cube root of 10 can be rewritten as 10 raised to the 1/3, but then all of that squared, so that becomes 1 over 10 to the 2/3, and then say that your answer choices all have negative exponents. What would the final answer be? Right, 10 raised to the negative 2/3. Okay, everybody understand? Okay, so you're responsible for all of page 1 and all of page 2. It shouldn't take you that long.